Alrighty, next section is 4.3, and this one starts out happy, and then in a bit it's going to get a little eh. So anyway, um, we're going to start with vertical translations. So what a vertical translation is, if I go to Desmos, we can see, oh, I got Desmos, got rid of it. But anyway, if we go to Desmos and I type in a sine wave, then I can add something after the fact. In this section, they call it K. And here, if I hit play, notice that all this adding a number does, if you add it after the fact, is it moves the graph up if it's positive, and then if it's negative, it moves the graph down. So let me graph the original sine of x below for comparison. Change the color to make it black. All right, so the original sine is right there, and you can see that if it's positive, it goes up, and if it's negative, it goes down. So that's all adding a number after the fact. And when I say after the fact, I mean it's not inside the function, it's outside the function. So anyway, the graphs of, get my pen, sine of x plus k and cosine of x plus k will be, let me turn the screen off, will be the sine and cosine graphs that have been translated vertically k units upward. And remember, when it went up, if k is greater than 0. So again, if k is positive, then the graph went up, or k units downward if k is less than 0. And again, less than 0 means negative. All right, so that's basically it. Let's look at our first example. It says, sketch the graph of y equals negative 3 plus 2 sine negative pi x. So our first task here is to write the equivalent expression. What I'm going to do is I'm going to put the sign first. And then notice that also this is odd. And so when it's odd, that negative sign can move to the outside. So this becomes negative 2 sine of pi x. And then we have the minus 3 after the fact. Oops. And so I can say minus 3. So this is the same equation. I just kind of changed it, made the inside positive using odd functions, a property of odds, and just rearrange things around. So anyway, looking at this, we can see that the amplitude is 2, or the absolute value of negative 2, which is 2. All right, the period, we can use what we learned last time, is 2 pi over the number in front of x, which is pi. So the period here is 2, which means, and they didn't ask for it, but the length of each quarter is 1/4 times 2. And so that's just going to be 1/2. All right, now the range is going to be a little different. Notice before, whenever the amplitude was, that kind of was the range. So it means that we're going to start at negative 2 to 2. But remember that we went down 3. So that means in addition to this, I'm going to have to do minus 3 from the start, or the beginning of the range and the end of the range. And when I do that, that gives me my new value. Negative 5, comma, 2 minus 3 is negative 1. So my new range is negative 5 to negative 1. All right. So we know that each tick mark has to be a half, because that's what each quarter is. So let me go ahead and start labeling. All right. Let me get rid of this. Not right now. Okay. 0.5, 1, 1.5, 2, 2.5, 3, negative 0.5, -1, -1.5, -2, -2.5, -3. All right, and we know that our range is from -5 to -1. So here we have -5 down here, -1 over here. And let me zoom out a bit. All right, so here my x values are going to be, again, each quarter, each tick mark. So 0, 0.5, 1, 1.5, and 2. That's one period. And remember that this is a sine wave. Okay, it's a negative sine wave. Actually, in this case, the negative is taken care of. What I filled in for you here is basically the equation. The equation is -2 times, and then there's all your sine stuff, -3. Now the y value for sines go here. And again, if you're thinking of sine wave, that starts there, goes like that. So it's 0, 1, 0, -1, 0. And so doing that, we can get -3. -2 minus 3 is -5, -3. Then we get 2 minus 3, -1, and then back again to -3. So I can plot those points. And so notice it's the same pattern as before, it's just that the graph went down by 3 units. All right, and then I can extend the picture if I want by just putting dots continuing the pattern. Okay, so I'm going to put a dot up here, dot here, dot here, 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 and here, and I can continue the pattern of my sine wave. Okay, but overall, same idea as before. The tick marks are just each quarter for the x values. The y was -2 to 2, but since it was a shift downward, we moved everything down 3. So instead of from -2 to 2, it became -5 to -1. Other than that, it's exactly what we did in the previous section. So let's move to the next page. Now, this is the answer that we got from the word problem in chapter 3 with the whole Ferris wheel thing. And what they want you to do is they want you to sketch the graph that shows your height on the Ferris wheel. So first, what I'm going to do is write the equivalent expression. Usually what we want to do is we want to put the trig function first, and then you put the number second to show that it's after the fact. So my equivalent expression is -125 cosine pi over 10t plus 139. And so here we can see that this graph is going to go up 139. Okay, the period is still the same as the last section. It's 2 pi over the number in front of x, which in this case is pi over 10. We can do some quick math. I can multiply it by 10 over pi, multiply it by 10 over pi. Those cancel. The pi's cancel. And you can see that 2 times 10 is just 20. So my period is 20, which means that each quarter is going to be 1/4 times 20, which is just 5. So each tick mark is going to be 5. So I go back down to my graph, and I have 5, 10, 15, 20, 25. Okay, so now we have our x labeled. The amplitude of this graph, it's the number in front of the cosine. So it's the absolute value of -125, which is just 125. So normally the range would be negative 125 to 125, but notice that we went upwards 139 units. So that means that I'm going to go up 139, up 139, and that gives me my new range. So my new range is 14 to 264. So if I'm labeling, here I did this one a bit different since the numbers are so weird. I'm going to keep a consistent scale on the y-axis, and basically what's going to happen is 14 is my lowest point, 264 is the highest point, and the number that we added, 139, is going to go right in the middle. And what my graph is going to look like is it's a cosine graph. It's a flipped cosine. So a flipped cosine would look like this. And so that's the basic idea that I'm going to do here. Right? I know my values are 0, 5, 10, 15, 20. And looking at, I don't really have to plug things in. You can plug the 0, 5, 10, 15, 20 in if you want. But I already know the basic shape of my cosine. It's going to start at 14, go to 139, go to 264, back down to 139, and back down to 14. So I kind of already know my values. 14, 139, 264, back down to 139, and back down to 14. Now to label this a little bit better, I'm going to go by 40s. And we can label. So the first point is 14, somewhere down here, making the points pretty big so I can generalize. 5 is 139, it's about right there. 10, 264. 15, 139 again. And 20 back down to 14. So connecting the dots, we can see that my cosine function looks like that. And if you wanted to continue the trend, this would be back up here. So it would go back up that way. Anyway, so if you're dealing with a graph where the tick marks are already written for you, here on the y-axis, I kind of had the tick marks already labeled. And so you could just kind of have to pick a number where they're evenly spaced. I know my answers are between 14 and 264. So given the number of tick marks, 40 would have been a good estimate. Anyway, so that's just moving the graph up and down. So let's go to the more complicated part, which is moving the graph left or right. This is where things get funky. So if I go back to Desmos, if I change, let me see if I can zoom this in. Nope. If I change the number being added to inside the function, let me get rid of K, and I hit play. So here it's kind of hard to see, depends on your perspective. But notice that as I move it to the right, it seems like the graph is flowing to the left. As I move it to the left, it seems like the graph is flowing to the right. So it seems like it's doing the opposite thing that that you're plugging in. I can show this again by instead of sine of x, I can change this to x squared, something that you're more familiar with. Hide that. And so notice that as I go to the left, the graph goes to the right. As I go to the right, the graph goes to the left. Now in math, to avoid that confusion, what they usually do is they change the way it's written. instead of saying x plus h squared, they'll say x minus h squared. And that minus sign does the flipping for you. And well, that's right, I can write on the screen. So this minus sign it corrects the opposite. I can't spell opposite, don't judge me. Behavior. So now if I go to the right, let me click on the pointer again, the graph now moves to the right. If I go to the left, the graph now goes to the left. So whenever you see the minus inside, all they're doing is they're correcting that opposite behavior. So when you're doing your math, it's not as confusing. Positive means right, negative means left. So anyway, going back over here, horizontal translations. My cat is sitting on my notes. All right, whenever a number is added or subtracted, and let me zoom back in. Ooh. Inside a trig function, the graph is horizontally shifted left or right. Right? So again, the period of sine, here we have the inside. Whatever you see inside, you put between 0 and 2 pi, just like we did in the last section. So if I have 0 less than or equal to x plus 3 less than... So this kind of explains the opposite behavior. Notice that when you had x plus 3, in order to fix it, you would subtract 3 from each side, and that gives you 0 less than or equal to x. Sorry. Wow, can't do basic math today. Negative 3 less than or equal to x less than or equal to 2 pi minus 3. Notice that the inside was plus 3, but the behavior is that we shifted left 3. So to keep the idea of the left in there, what we usually do, again, like I mentioned before, is we say that this equation was sine of x minus negative 3. Okay? That way, if we do that, minus 3 corresponds with left. And so it doesn't, you don't have to think of it as opposites. Same thing here. 0 less than or equal to x minus 3 less than or equal to 2 pi. So instead, I'm adding 3. And so my new expression becomes 3 less than or equal to x 2 pi plus 3. Okay, this is a right shift of 3. Three units. And again, to avoid the confusion, because notice that you look at that and you see minus 3, but it's going to the right. So in math, what they do, and it's a common practice, is we do x minus and then a positive 3. So you just change the way it's written. So that way positive 3 corresponds with right. So the graphs of sine of x minus h and cosine of x minus h will be sine and cosine graphs that have been translated h units to the right if h is greater than 0. And again, that's because of that minus sign that's already present. And translated h units to the left if h is negative. All right, so let's do a class exercise. Sketch the graph of y equals sine of x plus pi over 2. So again, my equivalent expression here is sine of x minus, and then the pi over 2. Oh, sorry, I already messed that up. Negative pi over 2. All right. My period is, so for the period, remember you just do 2 pi, or you know what? I'll prove it later, but for now let's just work like if we were doing it before. So I have 0, x plus pi over 2, 2 pi. If I subtract pi over 2, this becomes, I'll move this around later. So I have negative pi over 2, and then 2 minus a half is 3 halves. So this is just 3 pi over 2. So the period is just the distance between the two. So the distance between these two is 3 pi over 2 minus negative pi over 2. And notice that when you add those together, you're just going to get 2 pi. Now the shortcut for that is to notice that the number in front of x is a 1. And so the shortcut is just 2 pi over the number in front of x, which is 2 pi. All right, so however you want to deal with that, that's how you do the period. But I wanted to show you the long way to show that we're still doing the same thing. It's just that before, the number on the left had always been a 0. But now since we're shifting left and right, the number can be anything. So to find the period, you just subtract the two. 3 pi over 2 minus negative pi over 2. And so the distance between them is 2 pi. Right, so because of space, I'm going to erase this stuff. And I'm going to see if I can move this stuff over. So how can I do that? There we go. All right, anyway, amplitude. Okay, the amplitude is the number that's in front of the function. So again, the number in front of the function is 1. So my amplitude is 1. And so my range is just going to be from -1 to 1. Okay, I know this is a sine wave. And so a sine wave that's not flipped or anything looks like that. So I know these are going to be 0, 1, 0, -1, 0. And I almost forgot. If that's 2 pi, then the size of each quarter is just a fourth of that. And so that's pi over 2. So 0, pi over 2, pi, 3 pi over 2, 2 pi. And notice that I'm subtracting minus pi over 2. My h is this guy, which is going to go here, 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 and here. So negative pi over 2, negative pi over 2, negative pi over 2, negative pi over 2, negative pi over 2. So this is negative pi over 2, 0, pi over 2, pi, 3 pi over 2. So we have the points on our graph. Right? Notice that the y values stayed the same. All that happened was we shifted left of pi over 2. Right? So on your exam and on your homework, you're not going to have to show that much work. I just wanted to show you what's happening. We got the original values, and we just shifted them left by pi over 2. The y values for sine stayed the same. Okay, so now with that, let me go ahead and plot this. So I know the size of each quarter is pi over 2. Remember, those are your tick marks. So I have pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi. And then my range is 1, -1. And I can graph the points. At negative pi over 2, you had 0. And then the regular behavior of my sine wave. Oh, that's not it. Okay. Now what I want you to notice is that this sine okay, notice that this is exactly the same as cosine. So that just means that cosine is just a shifted sine wave. I can't write right now. Blech. So sine and cosine are just shifted by pi over 2. All right, I apologize for my handwriting. That's pretty bad on my part. Anyway, so what I want you to do, for this example, I want you to do this one on your own. And then you're going to see a link on Canvas below this lecture where you can see if you did it right. So I want to move on to page 5, which is creating the box. So I went really slow when I did every example I've done up till now. When you're doing this, usually you're just going to focus on creating the area where your trig function is. And your trig function can always be located within a box. Okay. Now the upper and lower bounds for your box are really easy. It's just the amplitude plus the shift. Remember, this k is your vertical shift. And then the left and right side, I could make a formula for it, but it looks kind of nasty. So why learn a formula when you can just do basic math? So to find the left and right, just put the inside between 0 and 2 pi, solve it. And the two sides that you get are your left and your right sides. So let's do this example. Sketch the graph of 4 cosine of 2x minus 3 pi over 2. So plus 1. And again, we're doing this without a graphing calculator, but it's actually not too bad. You have to think of the box first, and then you place the box inside your actual graph for context. So first, let's look at amplitude. I can see that the number in front of the cosine is 4. So my amplitude is just going to be 4. My range would be -4 to 4. But notice that there's a plus 1. So that means I have to do plus 1, plus 1. So my range is actually -3 to 5. Right? So that means that this is going to be -3. This is going to be 5. And the shift is what goes in the middle. And again, I'm just using... Notice I didn't really actually use the formulas. I just used kind of my common sense here. My range shifted up 1. So that's the upper and lower bounds of the box. Now the inside of the box, I have 2x minus 3 pi over 2. So I just do some basic math. Minus 3 pi over 2, 3 pi over 2, 3 pi over 2. So when I do that, I get -3 pi over 2 less than or equal to 2x less than or equal to, and then 2 minus 3/2 is just pi over 2. Oh, oh God. Yeah. It's not like in class where you can call me out when I make a silly mistake. All right, so it's plus 3 pi over 2. I apologize. I don't know what's wrong with me. You're weird, Gilbert. I know. So 3 halves plus 2, and you can just use your calculator here if you want. 3 halves plus 2 is 7 halves. So this is just 7 pi over 2. Anyway, and then the last step is to divide by 2. Or you know what, instead of saying divide by 2, I'm going to multiply it by a half. It's the same thing, and it makes life a little easier. So I can see here that my range is going to be 3 pi over 4 all the way to 7 pi over 4. And let me go ahead and shrink that. Let me erase some of the basic stuff so I have more room. And I'm going to get this and just move it up a bit. All right, so that means that the left side is going to be 3 pi over 4. The right side is going to be 7 pi over 4. Okay, my period is just, you take the sides and you subtract them. 7 pi over 4 minus 3 pi over 4 is 4 pi over 4, which is just pi. Also, you could have done 2 pi. My cat is having fun behind the TV. But 2 pi divided by the number in front of x. So 2 pi over 2 is just pi. So those are the two different ways you can find the period. Subtract the left and right values, or you can use the formula, where the number you divide by is always the number in front of your x. So anyway, length of each quarter is just 1/4 times pi. So that's just pi over 4. Okay? So that means that each of these tick marks is going to be pi over 4. So 3 pi over 4, 4 pi over 4. Let me put the tick marks on top. 4 pi over 4, 5 pi over 4, 6 pi over 4, and notice that we get 7 pi over 4. So this is just a cosine. Remember, cosine looks like that. So I'm going to start here, 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 here. And all I'm going to do is, here's my box with my picture inside it. I'm going to turn my box and fit it where it's supposed to go in the graph. So my box is from -3 to 5. And then from 3 pi over 4. So here's pi over 2. So 3 pi over 4 is right here. It's going to go to 5. All the way to -3. And then it's going to go all the way to 7 pi over 4. So there's my box. And I know that it's 1 is in the middle. And there we go. If I wanted to extend it, I just repeat the pattern. Okay. And then go back up here. All right, so that's the idea of the box. Your cosine or sine wave will always be inside a box where you can find the left, right, up, and down bounds of it. And from there, it gives you an idea of how to add it to the actual graph. Anyway, I know this is a lot, especially combining all these ideas in one problem. But anyway, we're almost done. So page 6. All right, so now let's try to formalize everything. If A and B are positive and C and K are any real numbers, then the graph of A, sine of bx plus c, and a cosine of bx plus c. Oh, I forgot to add the k. Plus k plus k. We'll have, and so this is the final summary of basically everything in chapter 4. So 4.1, 4.2, and 4.3 up till now have led to this. So when you're dealing with a sine and cosine, the domain is always negative infinity to infinity. That doesn't really. The amplitude is just the absolute value of a. That's what we learned in the last section. The vertical shift is just k. The range is what we talked about earlier. Notice the range is just the box. Negative absolute value of a plus k to absolute value of a plus k. I don't recommend using a formula. Just kind of use your common sense. But they're trying to formalize everything. Why can't I write that? Let's try it again. Right? Now, the horizontal shift is, well, let's look at the phase. I'm going to explain these two in the next section. So, right below. The phase is c. It's the number that you're adding to your function. Whereas the horizontal shift is negative c over b. The period is 2 pi over b, which we learned before. And the length of the quarter is just 1/4 times the period. All right. So the thing is, what's the difference between a phase and a horizontal shift? So the horizontal shift is just getting your equation, putting bx plus c on the inside, and solving it. So if you solve it, your first step is to subtract c from both sides. We get negative c less than or equal to bx less than or equal to 2 pi minus c. And then what you would do is you would divide by b. And you get negative c over b less than or equal to x less than or equal to 2 pi minus c over b. So what I want you to notice is the shift that happened. The original graph started at 0, and now we end up at negative c over b. That is the horizontal shift. And that's where that formula comes from. Right? So when you're comparing it to the original function, that's the shift. Now the phase is when you compare it to a graph that's already been stretched. So if I do the same thing, I have 0 less than or equal to bx plus c less than or equal to 2 pi. So what a phase is it's just comparing it to, my cat's chirping behind me. So the phase compares it to a graph that's already been, yeah. So you know what? That didn't go as well as I thought in my head. Let me show you on Desmos. All right, let me erase all this stuff. Okay. So let's say I'm dealing with sine of 2x. Okay. So the phase is, let's say, plus 1 or plus pi. This is the original. So this should be the one that's dotted, whereas this is not the original. So this should be the solid one. All right. So the phase, I'll put plus c, is just how the function changes from its original, or from the bx form. How much did it shift from sine of 2x? Whereas the horizontal shift is how much does it change compared not to sine of 2x, but compare it to just sine of x. And again, I had to look this up because it is confusing. Okay, so you know what? I'm just making life more confusing. The main thing you need to know is the phase is the shift of sine of bx, whereas the horizontal shift is the shift of sine of x. And that's it. That's all that we're doing. The phase is how much does sine of bx move, whereas the horizontal shift is how much does sine of x move. Now, when you're looking at the graph, the phase is just c, whereas the horizontal shift is negative c over b. Anyway, sorry for being confusing. Erasing all that. All right. Oh, almost forgot to prove the period. So to prove the period, you just subtract the two. And notice they have the same denominator, double negative. The c's cancel, and you get 2 pi over b. So that's the proof for why the formula for the period doesn't change, and that proves the horizontal shift. Anyway, so for this problem, let's identify the domain, range, amplitude, period, horizontal shift, basically everything that could possibly be done, we're going to try to find for this equation. So first I'm going to rewrite it. I have negative 3 cosine of 2x minus pi over 2. And this is minus 2. So I changed it so the k is on the outside. So I know that my domain is negative infinity to infinity. That never changes. Right? All the outside stuff is this right here. So I know that my amplitude is the absolute value of negative 3, which is just 3. I know my vertical shift is down 2. My range, remember the range would be negative 3 to 3 because that's what the amplitude is, but I went down 2. So that means I get negative 5 to 1. Okay? The phase, now we have the stuff on the inside. This is all the horizontal stuff. The phase is just the number that's next to the x. So this is, my phase is negative pi over 2. Which means cosine of 2x shifts by negative pi over 2. Right? My horizontal shift, okay, you can use the formula, or you can just, if you want, put this between 0 and 2 pi. So I have pi over 2, 2x, and then 2 pi plus pi over 2 gives me, did I get it right? Yeah. So 2 pi plus pi over 2 gives me 5 pi over 2. I had it wrong in my notes. and then I divide or multiply by a half. And so I get pi over 4. So we can see that my function shifted from 0 and it became pi over 4. So my horizontal shift is pi over 4. And that's the shift, or cosine of x. So that's the idea between phase and horizontal shift. All right, the period, we can use the formula. 2 pi over the number in front of x is 2. So that's just pi. And when I'm graphing this, I need to make tick marks. So the length of each tick mark is just 1/4 times pi, which is pi over 4. So a lot of stuff in this section, shifting left and right. But what I want you to do is try number 7 on your own. It's this whole blah. What you're going to have to do is create your box. This is a sine wave. So whenever your box is complete, you know that the graph has to look like this. Oh, it's a negative sine wave. So it's going to look like this. Wow. All right. And so once you figure out what your box is, you put your box inside this picture, and that's your graph. And be sure to fill in all this fun stuff. So give that a shot. I'll post a video to it in the link below this lecture on Canvas. Anyway, let me know if you have any questions, and have a good virus-free day.